Hello, everybody. Welcome to today's lecture. So today we want to continue on in Chapter 6 and start talking about some of the applications of percents, some of which we've already kind of talked about, but I want to get more involved with that. So I mentioned last time we would talk about taxes, sales tax, and income tax, and we'll talk about percent increase and decrease a little bit more, and then we'll talk about simple interest. Okay. So first, sales tax. We already did talk about this, like I said, a little informally, but let's talk about it a little more formally. Um, we talked about it somewhere in 6.1 here. So in Kentucky, I believe that the sales tax is 6%. Sales tax is 6%. I'm gonna leave a question mark here to cover me in case I'm wrong. I live in Indiana, where it's 7%. I believe in Kentucky it's 6%. So what does this mean? Well, this means we did one example where we saw, okay, if our subtotal is say like $40, then what we would do is we'd find the tax on this $40. So the specifically the sales tax on $40. Okay. So to do this, we would find 6% of 40. Okay. And if you remember from the last section, this translates to we'd change the 6% into a decimal, so we'd have 0.06, and then we would multiply by 40. That of means multiply. So we change the percent to a decimal, and then we multiply by the second number. Okay. So we would do this. You can do it in a calculator. You should get 240. So the tax on the $40 is $2.40. Okay. So it's 6 cents for every dollar. You have $40. That ends up translating to $2.40. So now the total is going to be that $40 plus the sales tax, which is $2.40. Okay. So you're going to have altogether $42.40. Okay. Now there is a quicker way to do this. Notice that the sales tax increases the subtotal by 6%. Okay, that's what it's doing. So what does this increases by this amount of money mean? Well, we can do a little bit of a trick called factoring. So let me find right here. Okay. Our total here, let's forget the dollar signs for a sec, was 40 plus 240, and the 240 is 0.06 times 40. Okay. There's a little bit of a trick called factoring, which we talk about in a later section, so we haven't gotten there yet. But what that shows is that this is the same thing as 40 times 1 plus 0.06. Okay. So the 0.06 here is our rate, our R. We'll use the letter R to represent this. It's our rate or our percent. Okay. So this can give us a quicker way to do this. Okay, so our total, then, if we have this, is the let me use equal sign here. Our total is the subtotal, just like we had with the 40 here, times 1 plus the sales tax. Okay, as a decimal. So this is like a shortcut. So if our subtotal, let's say is like 37.29, right? It's not usually a even dollar amount, so it'd usually be something like this, maybe 37.29. Then the sales tax is 6%. This is 1 plus 0.06. Okay, so now we just remember our order of operations. We do the parentheses first to get 1.06. And then we're just doing 37.29 times 1.06. Okay. So this is 39.53. I'm rounding a little bit here. So you don't necessarily have to go and find what the tax is and then go back and add it on top of it. You can just do the shortcut method of just multiplying by 1.06. Okay, because the sales tax is 6%. If it's not 6%, like if you're over in Indiana at 7%, then you end up doing 1.07 instead. And this works for any percent increase. If we say something increases, so increasing by how do I want to phrase this? By some percent, we can use this formula where we take the original value, which we would call P a lot of the time, and we multiply it by 1 plus R. Okay, this is typically referred to as the principal or the starting amount. Okay. And then this is our percent as a decimal. Okay. So the new amount would be this. If you increase something by whatever percent, you take the original amount, the starting amount, and multiply by 1 plus R. And this would work for decreasing also, except if you're going down, if you're decreasing, your R would be negative. So you would end up doing 1 minus R. Okay. So if something is, let's say like some shoes cost $60, but they are 40% off. Okay. They're 40% off. So we take the original price and we decrease it by 40%. So we take 60 and then we do 1 plus, or you could think of it as 1 minus 0.4 here, because that's 40% as a decimal. Okay. So when we're decreasing, we make it 1 minus. When we're increasing, we make it 1 plus. Okay. So 1 minus 0.4, which is 60 times 0.6, which is $36. Okay. So 40% off of 60 is $36. If you didn't want to use this shortcut method, how would we reason out this problem without it? Well, we'd say, okay, 40% of 60 is Well, we would do 0.4 times 60, which is 24. Okay. And then we take that 24 and we subtract it from 60, right? It's 40% off. So 40% is $24. So we take $24 off of that original 60 and we get 36. Okay. So either way, we end up at the same thing. All right. So that's how sales tax would work, and that's how percent increasing and decreasing are working. And I mean, as we saw, sales tax is really just raising it by 6%. Okay. So what would it mean if we say, okay, in quarter one, so here's another example. Okay. In quarter one, Q1, a company made $52,000 profit. And then in Q2, their profits increased let's say 125% from Q1. Okay. And then how much were the Q2 profits? Okay. Because this is often how profits of businesses are reported for public companies. If you really dig deep, you can probably find the actual amounts, but oftentimes like the headlines will just say like, oh, the profits are up this much money, right? So what does this mean? Well, we take the original amount, the 52,000, and we raise it by 1 plus R. Our percent this time is 125%, so it's more than 100%, but that's okay. We still just turn it into a decimal, and it's going to be 1.25. Okay. So this is 52,000 times 2.25. Whoops. And then you can just do that in your calculator. And you get 117,000. Okay. So you can see when we say we raise by 100%, 100% as a decimal would just be 1. Then that means we'd be multiplying by 2. So raising by 100% means you're doubling the money. Raising by 200% would mean you're tripling your money. Raising by 300% means you're quadrupling your money, and so on. Okay. Because you're always adding that 1 to it. If you're raising by 50%, then you're just multiplying by 1.5. Okay. All right. Let's talk about now income taxes. Okay. We'll just make it at the bottom here. Let's talk about income taxes in the US. Okay. And I'm gonna copy and paste the actual income taxes, so we're using accurate information. All right, so I got these are the current income rate taxes. Sorry, income tax rates. So as of 2020, so I believe this is if you were going to file, when you go to file your taxes in the year 2021, these are the rates that your taxes would fall under. So let's take a look at how these work. First, let me give you a rundown of how income taxes in the US even work. There's a lot of confusion about this in general. Um, it so don't feel bad if you don't really know how this actually works, because it seems like most people really don't um know what the tax system we use is. Okay, so the common misconception is that if you make, say, like $45,000 a year, the common misconception is that that means that that 45,000 is taxed at 22% because it falls into this rate. But that's not actually true. It's only the money that you make above the 40,126 that is taxed at the 22% rate, and the rest of your money is taxed at 12% or 10%. So the majority of it is actually going to be taxed at 12%. Okay. This leads to a lot of common misconceptions, such as people believing that if they get a raise, it'll knock them into a higher tax bracket, and therefore they'll make less money. But that's impossible. Okay, if you get knocked into a higher tax bracket, or if you get a raise, I should say, you're always going to be making more money in terms of taxes. Okay, taxes aren't going to ever make you make less money because it's only the new money that's taxed at a higher rate. Now, that can come into effect with what's commonly known as the welfare cliff, which is that if you receive any kind of government assistance because you make under a certain income, then all of a sudden you get a raise and you make too much to qualify for that government assistance, but not enough to actually afford the stuff on your own, right? Then overall, you're really taking in less money over the year. But just in terms of income taxes alone, you will never make less money by getting a raise. Okay. So let's just take, for example, that 45,000. Let's say someone makes $45,000, okay, a year. And then how is this going to work out? So the first $9,875 are taxed at 10%. Okay, so we're going to find their income tax. I should also mention this is the federal income tax. You also have state income taxes. So the first $9,875 is always taxed at 10%. So we're going to do 10% of 9,875, or 10% times 9,875, because that's what that word "of" means. Then the next, all the money between 9,876 and 440,125 are taxed at 12%. So how much money is that going to be? Well, it's going to be the 40,125. We'll put this in parentheses, minus, oops, sorry about that, minus 9,875. Okay, so we subtract off the first number because we already accounted for the first $9,875. So whatever this number is times 12% now, 0.12. And then finally, we're going up to 45,000. That's falling in this range. So now we're going to do 45,000 minus the first 40,125, because we already took care of that, times 0.22, because that's 22%. Okay, and this will give us our income tax rate. Let's just simplify the parentheses first. Okay, so we can see exactly how much of our money is taxed at what rates. So 40,125 minus 9,875 is 30,250. Okay. And then 45,000 minus 4125 is 4875. So our first $9,875 are taxed at 10%. Our next $30,250 are taxed at 12%. And then the remaining $4,875 are taxed at 22%. Okay. So it's not the case that at 45,000 you get taxed 22%. Okay. It's only the money you make over the 40,125 that's taxed at that rate. The majority of our money is taxed at 12%, as we can see with the 30,000. So now we can just put this in our calculator here, as is. See what it comes out to. So I'll just do that here. Oops. And I get $5,690. Okay. So overall, somebody making 45,000 would pay $5,690 in income taxes, federal income taxes. Sometimes we talk about the effective tax rate, which is that you take the amount of money you pay in taxes and divide by your income, and that'll give you the percent that you actually paid in taxes on all of your money. And the effective tax rate here would be 12.6%, because you just take that 5,690 divided by 45,000. So overall, on all of our money, with the 45,000, we end up paying 12.6% to the federal income taxes. Okay. And then you would, if you wanted to know like how much of each of your check, would come out for federal income taxes, if you get paid, say, biweekly, there's 52 weeks in a year, so you divide by 26 total paychecks. So 5,690 divided by 26 would get you to $218.85 for federal income taxes. Okay. All right. So the highest tax rate we have is 37%. So that's if you make more than 518,401. You might have seen in the news recently there was a lot of talk about Biden's tax plan, which he proposed, which was that he was going to raise the taxes on people making over $400,000. So even then, still, it's not all of your money over. Like if you raise it to say like something really high, like 80%, I don't know what the actual number was. It probably wasn't that high, but if you raise it to like 80%, it's not that if you make $400,000, they're going to take 80% of your money. It's only the amount over 400,000. So if you make like 425,000, it's only that remaining 25,000 that would be taxed at 80%. Okay. It wasn't that high, but these tax rates, like 37%, it might seem, like a big number compared to the lower tax rates, but these are actually way lower than they used to be. Like back when like FDR was president, the highest tax rate was like 90%. Okay. So these have gone way down over the years, especially the upper rates. So let's go ahead and talk about the last thing here in this chapter. Let's see where we're at. 24. All right. In 6.4, which is simple interest. Okay. So this is kind of like the last application for percents that we have in this book. Okay, so simple interest. So interest is something probably everybody has encountered at some point. If you take on a debt, usually you have to pay interest on that debt. Or if you put money in a savings account, usually you'll get paid interest, right? So simple interest is a So interest, first of all, interest is kind of money you pay in exchange for borrowing money. Okay. So you borrow money and in exchange you pay interest. If you put money in a savings account and get paid interest, that's essentially your bank borrowing your money that you put in the savings account and paying you interest for it. They take the money you put in that savings account and they invest it and try to make themselves money. And in exchange, they pay you an interest rate. Okay. So simple interest in particular is interest that's only paid on the original amount. So it's not paid on any new interest. Okay. So let's go ahead and define that. Simple interest is interest which is only paid on the initial amount. Okay, which we call the principal. We used that word before, right? So it's only paid on the initial amount. Okay. So the formula for interest is as follows. I, the interest, is equal to the principal, P, times R, the interest rate, which would be the percent, times T, which is time. So I is interest. Okay. P is principal. R is the rate, your interest rate, which will be a percent, but you're going to write it as a decimal. And T is your time. Okay. And it's typically in years. So for example, if we put $500 in an account with 2% interest for 5 years, then how much will we make? Okay. Well, just based on our formula here, let's see. Our interest is equal to the initial amount, which is $500, right? That's the amount of money that we put into the account. Our rate, which is 2%, and we write it as a decimal, so 0.02. And then our time, which is 5. Okay. So we put these all together. We get 500 times 0.02 times 5, which is $50. Okay. So after 5 years, you would get an extra $50 in interest. Okay. So like I said, this is via simple interest. In practice, a lot of interest is typically compound interest. Okay, compound interest means that you get interest on the principal plus any previously accrued interest. So after the first year, for example, here, if you're making if you have a 2% interest rate at with $500, you would get $10. So then in the second year, now you have $510, and then you would make 2% off of that whole 510. That's how compound interest works. Here, you're just making 2% interest on that initial 500 every time. Okay. In practice, most things are compound interest though, and compound interest gets big really fast. Okay. If you were to graph simple interest versus compound interest. Okay, simple interest would look like a straight line. Okay. Whereas compound interest, it would look similar at first, but then it would start getting big really fast. Okay. This one's called a linear graph. This one's called an exponential graph. Okay. So how much money will we owe after 10 years if we borrow $1,200 at say 20% interest? Okay. And make no payments. Okay. All right, so we borrowed $1,200 for 10 years and it's 20% interest. Okay, so it's a pretty high interest rate, 20%, right? So that means you're paying basically 1/5 of the money every year in interest. It depends on the context. Like that's closer to like a credit card interest rate, or like the higher end of what car loans can get to. So if you make no payments, you can imagine if you make payments, it's going to be more of a complicated question because it's how much are you paying? How often do you pay it? Right. So this is kind of an unrealistic scenario because it's pretty unrealistic to think, okay, I could just not pay this for 10 years because in reality, what happens is if you don't pay it, it ends up going to collections, right? And then you owe somebody else the money. So, this isn't necessarily something that would happen in practice, but let's think about it still. So let's first calculate how much interest we would owe. Okay, so I is equal to P, which is 1,200, times the interest, which is 0.2, because it was 20%, times the time, which is 10. Okay. So if we put this in a calculator here, we should get 2,400. Okay. So the interest we owe is 2,400, and now we also want to add on the initial amount, right? So we have 1,200 plus 2,400. So we get 3,600. Okay. Now, just like before, this is like talking about a percent increase. So you can also just use the formula P times 1 plus R, just like we were back in 6.3 when we had it right here. Okay. That would work just as well if we did 1,200. Sorry, it would have to be 1 plus RT because you have to take the time into account. Okay. Because the time would tell you how many times you're charging that interest rate. Okay. So it'd be 1 plus 0.2 times 10. And that should also give you 3,600. So that's an alternative way to do it with a formula, but you can just do it this way if that makes more sense. So after 10 years, you owe $2,400 extra in interest. And then you also have to take into account that initial $1,200 that you borrow and have to pay back. So altogether, you end up owing $3,600, which is triple the amount. Okay. All right. So, like I said, simple interest isn't super common, in the real world. Some big loans like mortgages are sometimes controlled by simple interest. But a lot of things are controlled by compound interest, like credit card loans, car loans, student loans. They're all controlled by compound interest, so they get big really fast. The mortgages, for example, aren't, because they're really big loans and they're typically over 30 years. So if they were compound interest, they would get big way too fast and it would be almost impossible to pay them back. Okay. Um all right. So yeah, so that's all of the applications for percents that I have for you guys. So we're going to stop there for today. Next time we will go back to chapter 5 and finish up those application sections, and then we will see where we will go from there. So thank you for watching today, and I'll see you then.